Hey guys, welcome back to another video. In today's video, we'll be discussing ridge and lasso regression, which are regularization techniques that you will see often. In order to understand these, I recommend you to watch some videos on bias and variance trade-off, and also you can watch my previous video on linear regression in order to better understand how ridge and lasso regression work. Alright, so if you have met those prerequisites, let's get started. Okay, so let's use screen. Alright, so let's start with ridge regression, right? So let's say in our data set we have house size and house price, right? And this is a linear relationship. So let's say we only have two data points. So if you don't know how these work, basically if you know the house size, you can tell the house price, right? This is the x value, and then the house price is the y value, right? So, and the goal of linear regression is to fit a best fit line to the data, right? Oh, that's a terrible line. Let me redraw that. Yeah, to fit a best fit line to the data. And if we only have two data points, right, then our sum of residuals, or also our cost function, will be 0. So if you're not sure what that is, our cost function, or it's also known as loss function, so if you hear that, don't get confused. So our loss function, we're using sum square residuals, which is basically the sum of the difference between the predicted value and the actual value, and then you square that. Okay, so then it's yi minus y hat. Yeah, so y hat here is the predicted value, which is what the blue line represents, right? So if we take this here, for example, and we know the x value, we can tell the y value, right? We're predicting it. This is an actual data point that we have, but we can predict how much it will be, right? And now if we only have two data points, our sum of square residuals will be 0, because it's aligned, so that there won't be any difference between the actual value and the predicted value. And that's not good, right? Because if we have new data points, for example, let me choose a different color. If we have data points over here, 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 right, then this line will be terrible, because the sum of square residuals will be a very large number, and we're trying to minimize this cost function. We're trying to minimize this. So having a large number for the for sum of square residuals is a bad thing. All right. So then, how do we deal with this problem? How can we reduce the sum of square residuals while only having these two data points? Well, that's where ridge and lasso regression come into play. So let's talk about ridge regression first, right? So ridge regression, if you're familiar with if you know how linear regression works, ridge regression and lasso regression won't be much different. So what you do is you take the sum of square residuals, and then you add to it the lambda times slope square. So you might be wondering, wait, why am I doing this? And what the hell is lambda? Sorry for swearing. Well, in this case, Um, we'll get in more detail how we find the optimal lambda, but let's set this to 1, for example. And the slope here is the slope of this line. And, this is a line. And we can get the slope. So for this case, in our example, our SSR is equal to 0, right? Because the difference here is 0. And then if we set our lambda to 1, sorry, that's not a 1. If we set it to 1, and then let's say our slope here is around, 1.6 square, right? Then you see our sum of square residuals is greater than our original 0, right? So we're increasing the cost function. So you might be wondering, why are we doing that? Aren't we trying to reduce the cost function? So yeah, that's why it might not be very intuitive at first, but doing this can allow us to make better predictions later on. And so for this line, we're penalizing a higher slope, right? Because for a higher slope, we will have a higher cost function, right? So in order to reduce this, oh, sorry, I didn't mean to cross that out. In order to reduce this, we have to have a lower slope. Let me use a different color, let's say dark orange. All right. And in order to do that, for a lower slope, we might have a line like this, right? Now, what this line does is that it fits the, it fits the testing data, these new data points, a lot better, right? But for the old data, it might not be as good, the difference, the sum of square residuals here is obviously greater than our original sum of square residual, right? Without adding lambda times slope squared. So by doing this, we're allowing our sum of square residual for the testing data to be a lot better, right? This sum of square residual difference between the actual value and the predicted value squared, it's going to be a lot less, because we're penalizing higher slope. So, and we're trying to reduce sum of square residuals here, for ridge regression. We're trying to reduce this, we're reducing this, right? So we're penalizing a higher slope. And so that's why we're reducing the slope, and that will fit the new data better, right? Okay, and so when do we use it, right? Let me switch back to the original question. So when do we use ridge and lasso regression? Well, we use it when we want to reduce overfitting. And overfitting is also called high variance. You should be familiar with the bias variance trade-off. High variance. Okay, so we're introducing some bias in order to reduce the variance. Also meaning reducing overfitting, right? So we have a lower variance now. And yeah, that works well for both ridge and lasso regression. But yeah, this right here, this is ridge regression. Ridge, I can't spell, my bad. Ridge regression. Sorry, my handwriting isn't the best. I'm writing on a tablet right now. Let me make that look better. Ridge regression. Okay, this is the formula for ridge regression. And so let's move on to, let's see, what else do we have? Oh, yeah, I mean, also, we're assuming that we only have one independent variable here, right? Well, we only have one feature here, right? So, but what if we have two features here, for example? Then we will, yeah, not independent variable. If we have two features, let's say we have house size, and we also have number of rooms, right? Let's say if we have two features, then our ridge regression would simply be sum of square residuals plus lambda times let's see slope 1 square plus slope 2 square. Right, so this is pretty simple. We're just adding another slope in here. And if we have 3 features, 4 features, number of fans, number of bathrooms, whatever, we just add their slope squared in here, right? Okay, now let's move on. That's not what I want. Okay. Now, let's talk about Lasso regression because it's really similar, trust me. And let me show you the formula for Lasso regression. It's simply sum of square residuals plus lambda times absolute value of slope instead of slope squared. So why do we do this? Oh, wait, let me write this first. Lasso regression. So why do we do this? Well, having absolute value instead of slope squared, we're actually able to remove the features that we don't want, right? We can reduce them to 0, if that makes sense. So as lambda increases, right, then our slope values would it will have higher impact on the slope, so our slope will get less steep over time. And so if we go here, if we have a high lambda, our slope will reduce. Now, so how do we find the optimal value of lambda? Well, we typically use something called tenfold cross validation, right? Not bad. Not used to using tablet validation. And we're trying to find the lambda value that will give us the least variance, right? To reduce variance. That's our plan with regularization, to reduce high variance, right? And so over here we have the absolute value. So what you have to know is that Lasso regression simply it helps us with feature selection. The unimportant slopes or the unimportant features will be set to 0 because it's absolute value here. So you can use Lasso regression for feature selection. So unimportant features are removed. So that's the main difference, right? That's the main difference. This is the big difference between ridge and Lasso regression. So how do you choose between the two? How do I know should I use ridge or Lasso regression, right? When to use, right? So You typically use, let me write it down. You use ridge regression when most of your features, variables, features are useful, right? So, and why is that? Well, since we have slope squared here, it will never reach 0. That's what you have to know. So it won't completely remove the features. But if we use lasso regression, it will completely remove the features, right? So you use lasso regression when we have a lot of features that could potentially be unimportant, or too many features, so we don't really know if they're important or not, right? So that's what we can do. It helps us with feature selection. Well, let me write it down too. Help with feature selection. So yeah, lasso regression helps us with feature selection. And that's pretty much all you have to know, the main difference between them. And yeah, I feel like that's really it. Am I missing anything? Let me think. I think that's all. So let's go over our main ideas, right? So, up here, oh, right, one more thing. So, right, when to use. We use, let me put these in bullet points. We use regularization techniques when we don't have that many training data. Right? When we don't have that many data. So if we go back here, right, we only had 2 data. So our sum of square residual is 0 because, it's fitting perfectly to the line. Right? It's fitting perfectly. So if we have little data, right, let's say if we have another data point here, right, then it will still fit the data set really poorly, right? So we use regularization methods when we have little data, and then we're trying to reduce the overfitting, right? When we don't have enough data, we tend to overfit our training data, right? And it won't work as well on testing data. So we're trying to reduce overfitting. And to do that, we're using ridge and lasso regression, right? So let me write the formula for ridge regression again, because I feel like it's not really clear. It's basically sum square residuals, which I wrote up here. Sum square residuals plus lambda times slope squared, right? Lambda times slope squared. And lambda, we are using tenfold cross validation to find the best lambda value that minimizes the variance, right? And the larger the lambda value, the less the slope value, right? Because we're penalizing the slope as much as possible. And right, it will eventually approach 0, at slope 1, slope 2, all the way up to slope n. It will eventually approach 0. Okay, so yeah. And we have lasso regression, and the difference between them is that this one's absolute value, which causes unimportant features to be completely removed. So it helps us with feature selection, which could be very useful here. And yeah, I feel like that's basically it. What else? Yeah, I think that's a good wrap to this video. My bad. Yeah, so if you haven't checked out my previous video on linear regression, please do so, because I think it will definitely help you to understand this video. And also, I highly suggest you to watch something on bias variance trade-off, because it's basically the trade-off that happens throughout machine learning. Like, you'll see it everywhere, so it's important to understand them. And linear regression is really useful, and you should definitely understand linear regression. You will also see it in deep learning when you're learning neural networks. And so, yeah, I made a video on that. Please check it out if you haven't. And yeah, that's it for this video. If you guys have any suggestions, feedbacks, or questions that you still have, please leave them down in the comments below. Please, please, please. I would really love to improve my videos and also help you guys out if you have any questions. And teaching is a way for me to improve myself as well. So thank you guys for watching. I hope you enjoyed this video, and see you next time.